We're going to look into what is the technology behind digital assets, which is your distributed ledger technology. We will then get into the features of these different assets. What are the forms of investing in them? And then, of course, as always, we'll look at the risk, return, and then diversification benefits. Now, this is a new asset class, right? It's a new investment class coming up, and you can look at it in terms of various perspectives, in terms of as a store of value or a way to securitize things, right? Which is the ownership. So you can own pieces of real estate through them. You can own pieces of companies through them. You can even have utility tokens, which is a right to use, maybe a right to vote. So a lot of different perspectives are developing here, and we're going to look at all of them. So overall, what is this learning module going to cover? The technology behind this, right? The features of these assets. What are the forms and the vehicles through which we can invest in them, and of course the risk, return, and then the diversification benefits. So let's get started. And let me take a step back here and help you understand the context, the history. And you might have already heard this name, Satoshi Nakamoto, the guy who came up with the Bitcoin white paper. So what was going on at that time, right? What were these guys thinking? What was the time? So this is around the 2008 financial crisis time. And this community that they were part of, that what were they talking about? What were they angry about? Their problem was that, hey, look at what the Federal Reserve did, the US Central Bank. They just printed money and they bailed out whoever they wanted to bail out. So these guys were not very happy with the fact that why does the government or the central bank get to choose who to save and who not to save? Why did they not save Bear Stearns or Lehman Brothers? Why did they choose to save whoever they did save? So they said, hey, that's not fair. Why should they get to choose? And what these guys said was that there should be no central body that controls something as important as money. But the problem they were facing was that if there's not going to be a central body, then who's going to say that, okay, this is how much money you have in your account and this is how much money you have in your account? How are we going to have an agreement, or how are we going to have a consensus on the fact that how much money is in your account, right? So what is, in terms of the ledger, what is your account balance and what is my account balance? How are we going to agree on that? And that's where this guy, Satoshi Nakamoto, it's probably not his real name, right? It was just his, the name he was showing on that platform on which they were talking, is that he came up with this mechanism, which is the consensus mechanism, where a lot of different computers, so these nodes, these are all different computers, they could come online and they could all have the same copy of the ledger and confirm to everyone that yes, this is the correct copy of the ledger, which has all the account numbers on it, the wallet IDs basically, and the corresponding balance in each wallet. And the way this is done is it's done in blocks, right? So hence the name blockchain. What happens is they're all going to agree on one set of ledger. Once that is done, so that will be a block. And then again, after a few minutes, there's going to be an updated set and that will become another block. And once one block is finalized, then that's fixed. Nobody can change it. And then the second block, and then the third block. And on comes the next block, and the previous blocks are freezed. That record is done. Now there's a lot of positive things here, there's a lot of negative things here, and we're going to get into each of those. So there can be potentially infinite number of nodes. And we'll get into something which is permissionless versus permissioned networks, right? Which means Bitcoin is a permissionless network, which means anybody who wants to become part of this consensus mechanism can bring a computer, plug it into this internet, and become one of the nodes, right? So it's a permissionless network. Nobody needs permission to become part of it. Now, there are some permission networks, such as there is a currency called Ripple or XRP, which is a permission network. So now again, it kind of defies that original concept of Bitcoin, that there should be no central party controlling the currency. But then obviously there are benefits of having a central party, right? So that's where now we have new cryptocurrencies that are coming up, which are permissions. And what happens is, then obviously in that case there cannot be an infinite number of nodes, right? Because nobody without a permission can become a node. So permissionless, yes, there can be infinite number of nodes in permissionless, but not in permission. Each node will have a copy of the ledger. There is a consensus mechanism that ensures that these ledgers are kept in sync, and that happens in the block. So one block will be finalized by everyone. When everyone says okay, done, then you move on to the next block, and then the next block, and that's your blockchain, right? And the previous records are considered immutable, that they cannot change once created. Now, how does this work? And where does the cryptography come in? So every wallet will have a public address, right? Which everybody will know. And then associated with that address, there will be a private key. Well, it's not one key, it's a set of keys. So let's just say, for simplicity's sake, let's say there is a private key which only you have, right? Nobody knows that. And now let's say from your public wallet address, and then this is my address, and you're transferring some money to me, right? So if you will announce to the blockchain that, hey, to the network, hey, I have transferred 1 Bitcoin to this address. Associated with that signal, that information that you will send out, there's going to be a certain verifying signature that you will send with it, right? And all those nodes, they're going to use cryptography to confirm that yes, it is you, the owner of this public address, because it's your private key which is signing off on this transaction. And that's how they will make sure that this transaction is valid, and everybody will then deduct 1 Bitcoin from your balance and add 1 Bitcoin to this balance, and then everybody will update their ledgers, and then we'll move on to the next block. So this is how it works. Now, what are smart contracts? So once this technology was developed, and the world realized that, okay, that's nice, so we can have a kind of cryptographic use of technology to use people's electronic signatures and get them to sign on contracts, right? So there are so many other uses of this, such as, for example, insurance, car insurance, right? Auto insurance, pay as you drive. So as you turn the car on, there is an electronic smart contract initiated between your car and the insurance company that please activate my insurance. And then when you turn the car off, the insurance is finished. So you only pay for the duration that you're driving. You don't get the insurance for the full year. So I'm just giving you an example that what is the use of smart contracts. Of course, there's a lot of other uses going on. And something which we're going to talk about a little bit later is how we can use this technology to not just create digital assets, but also even tokens that can be used to trade other types of assets like real estate or companies. So stocks, for example, like we trade in the stock exchange, are currently having a T plus 2 settlement, which means if you open an account with the broker, you put the money in and you say, okay, I want to buy Apple shares or Google or Amazon. It's a T plus 2 settlement, which means it takes 2 days for the money to go from your account and the shares to be deposited in your account. Now, consensus mechanism can do that in probably a few minutes, right? Depending on something called the hash rate. But I don't want to get into that right now. But it's definitely not 2 days. So what we are seeing is that distributed ledger technology, which is this cryptographic way of signing off on transactions through your private key, definitely has some value to offer in terms of smart contracts, in terms of settlement, right? So T plus 2 settlement can be made faster if we use this technology. So that is there for sure. Right. And so what are we saying so far is that they allow us to create, exchange, and track ownership of assets on a peer-to-peer basis, right? And let's digest this. Creation of assets is one area. Exchanging of those created assets is there, or it can also be exchanging of other assets which are not created digitally, which could be units of real estate or pieces of companies, like shares of companies. So, and tracking the ownership. So your settlement and exchanging the consensus, they are separate benefits of DLT, and creation of assets is a separate benefit as well, right? So initial coin offerings, which we'll talk about as well. And then because of this consensus, you also have this benefit that there is no central authority to validate the transactions. But we have to understand all these things separately, right? You don't have to associate them all with DLT. They are, of course, associated with DLT, but they are modular in nature that you can pick and choose the ones that you like and the ones that you don't like. For example, if you take my personal perspective, right? I mean, what I don't like about the Bitcoin, which I like about the US dollar, is that the US dollar is backed by the Federal Reserve, which is backed by the US government, right? And even though the initial concept of Bitcoin was that, hey, why should we trust the government? But then, I mean, if you're not going to trust the government, then who are you going to trust? Who is Bitcoin controlled by? Some miners, right? Which is something we're going to talk about shortly, that who and how would control this permissionless network, that what is the sort of power that controls this network, and can it be hacked? So we'll talk about that shortly. So it's not like this network is free of problems. This can be hacked as well. So maybe you would rather put your faith in the US government than just a bunch of computers, right? Who are obviously controlled by people. So maybe I personally don't like the no central authority part. I like the central authority. So that's why maybe I'm not attracted to Bitcoin that much. But that doesn't mean I don't like distributed ledger technology, because distributed ledger technology does offer that benefit in settlement, right? I can use that consensus mechanism, that cryptographic verification of private keys to speed up my exchanges and track ownership, right? So I can use that technology to improve the settlement in my financial markets. I can use it to make my exchanges better and faster. But it doesn't have to be necessarily coming up with the currency. I can use my existing currency. My central bank currencies can be improved, and we'll talk about how central banks are using this. And we will also talk about other applications to securities and real estate, etc. But before we do that, we're going to have a lot more discussion about Bitcoin and Ethereum and how it tries to get rid of that central authority. Right. So, what have we talked about so far? DLT benefits include accuracy, transparency, and security in record keeping. That's good. Faster transfer ownership, very good. Peer to peer interactions, excellent. So, this is all very, very good. Very good benefits of distributed ledger technology based on cryptography and consensus. Excellent. Now, here's where the problem starts coming in, right? So, now what does Bitcoin say? Bitcoin says that, hey, we're not going to trust anyone except for our nodes. Okay, so you trust your nodes, but how does that work? So, the node has to do something called proof of work. They have to solve complex cryptographic puzzles, and which requires, so this requires computing power, right? And the whole logic of this is that there are so many nodes that, and there is so much computing power that for any one party to come to try and sort of overwhelm this network is going to require a huge amount of computing power to overwhelm them. And because they will not be able to do it, which is an assumption that they will not be able to do it, and therefore they will not be able to tamper with the record of the blockchain. So what's happening over here? There's a block, and then there's a next block, and this block is considered immutable, unchangeable. Why? Because all these nodes agree on it, right? And if somebody has to tell them otherwise, they would need more computing power than them. Now, the drawback of this is that we're talking about massive uses of energy just to bypass not having a central authority, right? Now, there is a sort of a change in this, which is proof of stake, where instead of using that computing power as sort of the currency in which you get a say, you can also just put money on the table, and whoever puts enough money on the table in terms of stake, right, they get to say which is the right version of the ledger. So what are we saying over here? Let me repeat. And we're still talking about permissionless, by the way. We're still talking about permissionless networks, which means anybody can become part of this. And if we're talking about within permissionless, if we're talking about proof of work, then you can become part of it. And what you're bringing on board is the computing power. And the more computing power you have, the more of a say you have. Versus proof of stake, you also can become part of it without any permission, and what you're bringing on board is money, so you're going to have a stake in it, right? So the more money, and here an example is Ethereum. So the more Ethereum you bring on board, so you say, okay, this is how many Ethereum coins I have, so you get more of a say in terms of saying, okay, this is the final version, or this is the correct version of the ledger. In terms of Bitcoin, it's the computing power that you bring on board, and then you get to say, yeah, this is the correct version of the ledger. So now comparing it with the Federal Reserve, saying, yeah, this is the correct version of the ledger that JP Morgan, Citibank, Bank of America, you have these many accounts, and in these accounts, this is the balance of each individual or this each corporate account or whatever, right? The Fed is saying that. Or you can have people with a lot of computing power saying, yeah, this is the entire ledger and these are all the balances of those ledgers. Or you can have people with Ethereum, if you're following proof of stake, saying that, yeah, this is all the ledgers and this is the balance of each ledger. So this is basically what's going on, right? And each ledger is, of course, in blocks and it's secured by cryptography. And then the next one and the next one. But the whole concept is that who maintains that? It's if it's proof of work, then it's the people with the computing power who say, yeah, these are the right versions. Or if it's proof of stake, then it's the one with the major amount of that currency, which is, yeah, these are the right versions. So how does it happen? Well, the transaction will be initiated by the buyer and seller. It will be broadcast to the network And there will be a public portion of that, and then there will be a private key which will generate a sort of confirmation that yes, this transaction has been approved by the owner of that wallet, which is the one giving away the currency. The nodes will validate that using the cryptographic process, right? And once it's verified, it will become part of the new block. So the updated ledger will increase the balance of the person getting the money and decrease the balance of the person sending the coins, right? And then this whole thing happens through cryptography. The old block is locked, the new block is locked, they're linked, right? And then that is done, and then you start work on the third block, and then this goes on, and this is called the blockchain. So what is the difference between proof of work and proof of stake? Well, proof of work is based on computing power, and proof of stake is based on how much money you're putting on the table, right? So an example of proof of work is Bitcoin. Example of proof of stake is Ethereum. Proof of work, the problem is very, very computationally expensive. That is why Ethereum is basically becoming popular as well, because their point is that Bitcoin is just not sustainable because it's very expensive to run. But then Bitcoin has come up with a lightning upgrade. So, I mean, I don't want to get into the details of Bitcoin versus Ethereum here. But the point is that Bitcoin is proof of work, requires a lot more computation, because their currency is basically that computing power. That's how they get a say into which is the right version of the ledger. And if anybody wants to crash this system, then obviously they need to bring on board more computation power. Which, by the way, on a side note, let me tell you, Google is coming up with something called a quantum computer, and it is possible that that one computer might be having more computational power than all of the Bitcoin miners combined. So that's going to be interesting to see. Anyways, so proof of work, how does it work? You have your miners with powerful computers. They, by the way, use the NVIDIA chips, I believe. So NVIDIA has been going up as well. Yeah, they use significant amounts of computing power, making it difficult for a single third party to manipulate historical data. Well, I would add here, difficult but not impossible. Take a look at Google's quantum computer. So that might be very bad news for Bitcoin. Right, that's where you get into proof of stake. That's Ethereum, right? And Ethereum is basically, it's not the amount of computing power you're bringing on board, but it's the amount of money that you're bringing on board, the stake, right? So how many Ethereum coins you have, and that's how much say you get. And that say is basically what says, okay, what is the final version of this ledger, that who has how much money in their wallet. So instead of the Federal Reserve telling us who has how much money in their account, it could be the people with the most amount of Ethereum. So that's what Ethereum is all about. One more thing, in terms of inflation. Yeah, so, going back to that whole Satoshi Nakamoto and how and why these guys wanted to come up with a asset or a currency which was not controlled by a central party. What they said is that, hey, these central banks, they just print money whenever they want. So printing of money is a major angle in this, right? Printing without check and balance. And that's where Bitcoin is different, because they've got a hard limit on this. And we'll talk about that shortly. There's a slide coming up in which we talk about that. I believe it's a 21 million coins or something like that. The slide is coming up. But there's a hard limit on the number of coins that can be there. Ethereum, on the other hand, is different than Bitcoin, not only because it's proof of stake, but also because the stakeholders, the validators, can, in addition to saying which copy of the ledger is correct, they can, I believe, also alter the amount of currency that Ethereum is printing. So there is no hard limit on this. It can be changed, right? Because it's not like Bitcoin that it is out of anybody's control, that the limit has been set in the algorithm itself. So nobody can change that. So in terms of inflation, Bitcoin has that hard limit that no more printing can be done after you reach that limit that has been set by Satoshi Nakamoto. But Ethereum doesn't have that. Right. So how does it work with the proof of stake? You have your stakeholders, they pledge their stake, and then they then control the entire situation and protect it from malicious parties. Right, now let's get into permissionless and permission network. So both Ethereum and Bitcoin are permissionless. So which means anybody with either computing power can become a Bitcoin node, or anybody with money can become a Ethereum node, right? So just bring coins and you are on board. So no need to take permission from anyone. You have Ripple, which is a permission network, also called XRP. That's their coin. Ripple is the name of the company. And they are using this distributed ledger technology, but it's more of controlled by the banks, for the banks sort of a situation where you have permissioned joining. You need permission to join, and mostly these big banks are actually joining that. So permissionless, anybody can come in, right? Everybody can see the transactions happening, no central authority, and Bitcoin is a popular example. This was actually the whole concept of Bitcoin, that it should be by the people, for the people. Permission is restricted. Not everybody can come in. There are controls. Not everybody has access to the ledgers, and even the authorities can be given the access to view the transaction history. Right, so from your curriculum, what's going on here? Obviously, your permissionless will be slower compared to permissioned, which will be faster because there's just less nodes, right? Here, you have membership is unlimited. There's going to be a huge amount of members. So naturally, what will happen is that the speed will be slower. It will not be cost effective because each member or many members will be required to validate the transaction, right? However, the benefit is that it's decentralized versus permission, which is partially decentralized. I mean, it's not one central bank, but it is still a limited number of people who control it because membership is limited in your permissioned networks. And therefore, the governance is centralized, whereas here the governance is decentralized. Right. So now things are getting interesting. Because even though we started with this, right? So within digital assets, you have cryptocurrencies, and within cryptocurrencies, you have Bitcoin, but then you have altcoins like Ethereum, which is proof of stake, and then you have Ripple, which is not just different in terms of it's not proof of work, but also it is permissioned. And then central banks are coming in and saying, okay, why don't we take our fiat currencies that we already have, like such as the yuan or the dollar or the pound or the euro, and use this technology to give people wallets to pay and use their private signatures to approve their payments, right? But the currency should be our currency. So that's where the central banks are coming in, taking the best part of the technology, but not taking that no central party situation. So the central bank is there, backed by the government, plus the technological benefits are there. So I think this is a very interesting space to watch, right? We'll talk about other breakups of altcoins, and then of course tokens. So the benefits of distributed ledger technology apply to not just currency, but apart from currencies. So you can have shares of companies, right? Any kind of securities. You can have utility tokens to use things, maybe to vote for something or to use electricity or anything, right? Governance tokens, again, in terms of voting rights and stuff. So you can use those tokens to voice your opinion. And the most interesting space is these non-fungible tokens. So fungible means like money is fungible, right? You cannot differentiate $1 from the other. So non-fungible means unique. And I personally find one thing very fascinating in this non-fungible tokens is that, what is it called? The board ape, I believe. The board ape art, right? So you've got these pictures, digital art, and they're pictures of like monkeys who are looking bored. So there's some very fascinating pictures, and you believe it or not, they started selling for millions of dollars, and then they crashed in prices to thousands of dollars. So this is what's happening with your NFTs. Right. I think let's take a break here before we jump into the details of all of these different boxes. So because it's important for you to study in breaks, and that's how the mind learns. So just take a break, get fresh. We'll come back, and then we'll get into the details of all of this.